Hello everyone, my name is Krishna Chaudhary. Today I solve internal two question paper with answers my under the guidance of Shaligram Prajapat sir. My name is Krishna Chaudhary and my roll number was IT2K2444. Enrollment number DE2402045. Now, second internal first question. The population of CD taken once in 10 years is given below. Estimate the population in the years 1925, 1975 and 1984. We have some data. We have years and population in thousands according to that. In 1921, 35,000 and 1991 is equals to 42. 1941 is equals to 58. In 1951 is equals to 84 and 1961 is equals to 120. 1971 is equals to 165,000 population and last one 1981 is equals to 220,000 population. Now let's build the difference table for that and we have X 1921, 1931, 1941, 1951, 1961, 1971, 1981. According to that, Y is equals to 35, 42, 58, 84, 120, 165, 220. Now delta Y 7. We get that Y 42 minus 35 is equals to 7 and 58 minus 52 42 is equals to 16 and 84 minus 58 is equals to 26 and 120 minus 84 is equals to 36 and 165 minus 20 is equals to 45 and 220 minus 168 is equals to 35. Now delta square y we get 9, 10, 11, 11, 11 by minusing each other in delta y. Now delta 3 y 1, 1, 0, 0 and delta q square double square 4 is equals to 0 minus 1 0 and delta 5y minus 1 upon में 1 delta 6 y is equals to 2. Formula y is equals to y is equals to plus 2. Now u y naught plus u minus 1 upon with 2 factorial into the delta square y naught plus u minus 1 u minus 2 and into the delta square cube y upon with 3 factorial. That was the formula for Newton difference method. Here we have x is equals to 1925, x naught is equals to 1921, h is equals to 10. Now a is equals to x x minus x naught upon my h, x is equals to 1925, x naught is equals to 1921, h is equals to 10. Now we get computing by each other 0.4 by computing each other. Now let's move to the second. Now let's move to the second part of that question. Y is equals to 35 plus 0.47 0.4 into the 0.6 upon my 2 into 3. Now plus 0.4 minus 0.6 minus 1.6 into the 1 plus 6. Now, now that method works like that and at the end we have computing all that solution and we get the final value of y is equals to 36.84. Now the population in 1925 is equals to 36.84 k because we have x is value is equals to 1925. Now move to the Newton backward difference. We have the formula y is equals to y naught yn upon में y is equals to u uh, So reverse delta yn plus u plus 1 upon with 2 factorial into reverse delta yn plus u plus 1 u plus 2 del reverse delta 3 yn upon with 3 factorial. Now we have computing that all, and we have the final result value because we have u value and y not, and we have x value. By computing all that value in that Newton backward difference formula, we get the value of y is equals to 185.61. That was the population in 1975. Now let's move to the third part. 1984, how many population? Let's calculate by central difference method. X naught is equals to 1951 h plus x is equals to 10, and now u is equals to 1984 minus 1951 upon by 10. We get computing that in Sterling formula, which is equals to y is equals to y naught plus u upon by 2 upon into delta plus y naught plus delta y minus 1 parenthesis close plus u square upon with 2 factorial into delta square y minus 1. We have continued that formula. By substituting value in that formula, we get the value of y is equals to 239.2. Basically that was the population, the 239.2k population in 1975, and 1984 population was that 185.61, and in 1925 population was 36.84k. Now let's move to the second question. Now second question was that a two-dimensional table is given below. Use a linear interpolation to find f 2.5 comma 3.5 where x y it's given below. We have that some additional data in question for solving that question. Let's see. Check first question. Generating the Lagrange interpolation algorithm to perform quadratic interpolation of function of two variable. And second part of that question is the use the algorithm to find f 2.5 3.5 for the above table. Now that question is easy. Let's check it answer. Theory two-dimensional interpolation is when the value of function depends on two variables x and y. Using Lagrange formula, f of x is equals to y naught x minus 1 x minus 2 upon my x is not minus x1 x0 minus x2 plus y1 x minus x0 x minus x2 upon my y1 x1 minus x0 and x1 minus x2 plus y2 x minus x0 x minus x1 and x minus x4 upon my x minus 2. We have that formula, Lagrange formula we also call that. Now substituting value 2.5, and we get the value is 2.5 minus 2 ब्रैकेट में minus 2.5 minus 4 upon में 2 minus 3 2 minus 4, and now we have substituted. Now for y is equals to 4, we have x comma y 2 is 2 3 4 upon man 2 29 49 50. We have that value of x and y. Now let's check the interpolation in y direction. In y direction f 2.5 upon in bracket में y, we have the value now 39.875, y is equals to 35. Linear interpolation p 2.5 upon bracket में 3.5, we have that value. Now let's compute it in that formula, and we have the final value is equals to 48.7775 for the second part of that question. Let's move to the third part. Now the third part of second internal, we have that integrate the function tabulate below using Simpson rule. We have some values of x and fx. Let's check it. What was the value? Minus 0.6, minus 0.5, minus 0.5, minus 0.3, minus 0.2, minus 0.1, 0, 1, 2, 3, and 42384 minus 2 2358 corresponding to the value of above. Now we apply the Simpson one-third rule is used for integration when data point are equally spaced. We have that formula of Simpson fx integration a upon a to the h fx dx is equals to h upon the 3 bracket में y naught plus yn plus 4 into the y1, y2 and y3 plus 2 into the y2 plus y1. Now we have h is equals to interval with y naught, y1, yn is equals to function value. Identifying value by fx minus 0.6 minus 0.5. Now we have h is n is equals to 6, h is equals to 0.5. But now we have simplified that and we get the value 22 plus 8 minus 2 is equals to 8. For 8 is equals to 32. Even terms we have 3 plus 4 upon is equals to 7 and 2 into the 7 is equals to 14. Now we have the 0.6 to the 0 limit we have, and fx dx is equals to 0.1 upon the 3 into 52. Now that final answer we get was that the 1.733. That was the final answer for the question 3. Now let's move to the question 4. Integrate fx is equals to 2x cube minus 3x square plus 4x minus 5 from minus 2 to 4, where a is equals to minus 2, b is equals to 4, take n is equals to 4, table of value of x coordinate and weight of our Gauss Legendre formula. We have some additional data given in that question by which we perform the question to answer. Now the answer. uh, we have the answer for fourth question. Fx is equal to 2x cube minus 3x square plus 4x minus 5. From 2 to 4 using Gauss Legendre formula, we have a is equals to 2, b is equals to 4, minus 1 is less than greater than equal to t and greater than equal to 1. And x is equals to b minus a upon by 2 plus a plus b upon by 2. Therefore, we have the formula minus 1 upon by 1 ft is equals to w1 ft1 plus w2 ft2 plus w3 ft3. Now v1 vw3 plus is equals to 5 9, w2 is equals to 8 by 9, and T1 is equals to 0.7745967, T2 is equals to 0, and T3 is equals to 0.7745967. Now we have the second step for that question, find function value by putting a T1, T2, T3 value in the above equation. Now we apply T1 value in above equation 2x cube minus 3x squared minus plus 4x minus 5. We get the solution is at minus 20.195, and similarly we apply the T2 in place of 2x cube minus 3x squared plus 4x minus 5 in the place of x. Now we have compute and we get the value is minus 2. when we apply 0. Now let's move to the T3 0.77455967. We all similarly we compute that question, and we have the result is equals to of fx value 49.195. Now let's apply the Gauss legendary formula. I is equals to 3 bracket में 5 minus 9 into minus 20 minus 195 bracket close plus 8 upon 9 minus 2 plus 5 by 9 18.1.5. I is equals to 3 minus. Now we have that apply the formula in Gauss formula, and we have the I value is equals to 49.334. That was the final value we get. Now let's move to the fifth question, fifth part of the question from an internal to. Now in fifth question, write a program or draw a complete flowchart Newton forward difference interpolation formula. Now we have include stdio.h int man. We have integer ijn and float value x upon x, array 10 up comma y 10 into 10 in array. Now we print enter number of data values by printf, and we have stored it by percentage d and printf enter x and y. Now we have uh, run the loop for I is equals to 0 to I less than n and incremented by plus 1. Now we have get values in I, j, and now forward difference table is equals to 4. J is equals to 1, j less than upon n, and we up incremented by plus 1. Y y1 into z in array y I plus 1 into z I j I minus 1 minus y I j minus 1. Now we have printf interpolation value and stored value interpolation, and x is equal to x1 minus x0. A is equals to value minus x upon 0 not. Now we have divided by h, sum is equals to y 0 0, p is equals to 1. For I 1 less than I plus incremented by 1, we have another loop. We have in that performing p is equals to p into I minus 1 upon my I, and sum by sum plus p into y 0 I. Printf interpolated value is equals to percentage f and stored at in. Now return 0, and after that we have completed it our C++ program for fifth question. And thank you for the uh, and thank you for the all the viewers who watched my video. Please like, subscribe and share my video.